This week, the Add to Cart button moved one step closer to extinction as Google launched a standard that lets AI buy things for you. A 50-year physics problem was solved using a trick borrowed from jewelry making, and a quiet manufacturing breakthrough may finally bring humanoid robots into real factories, not demos. I am Abhishek, and this is your weekly engineering brief. The Add to Cart button just became optional. This week, Google launched the Universal Commerce Protocol (UCP). Think of it as HTTP, but for buying things. UCP is a shared language that lets AI agents talk directly to online stores, browsing inventory, negotiating prices, verifying payments, and completing checkouts without a human in the loop. Instead of clicking through 10 pages to buy a pair of boots, your AI agent can search across Shopify stores and Walmart, pick the best option, and place the order instantly. This marks a real shift from the AI that recommends products to AI that executes decisions. We are moving from the era of search to the era of action. Stanford engineers just turned science fiction into material science. Inspired by octopus skin, researchers have developed a soft photonic material that doesn't just change color, it physically reshapes itself. Using nanoscale light, light cages, the surface can swell, rise, and form complex 3D textures in seconds. No pixels, no screens, the structure itself became the display. In lab demos, a perfectly flat film transformed into a miniature mountain range on demand. Beyond camouflage, this unlocks something even more interesting: haptic displays. Imagine a phone screen that grows real buttons when you need them, or a robot that can mimic the texture of its surroundings to blend in seamlessly. This week, physicists cross a line we have been chasing for 50 years. For decades, the nuclear clock was a theoretical idea, far more stable than atomic clocks but nearly impossible to build. The breakthrough came from a surprisingly simple idea: electroplating thorium onto steel, a technique borrowed straight from jewelry making. Unlike atomic clocks, which rely on electrons, nuclear clocks measure vibrations inside the atomic nucleus itself, making them dramatically more stable and resistant to noise. The impact is enormous: GPS accurate to millimeter, better synchronization for global networks, and navigation system precise enough for deep space missions. This isn't just better timekeeping, it's a new reference standard for modern civilization. While most of us use AI to write emails, scientists at Argonne National Lab just used it to rewire the energy grid. Their autonomous AI-chemist ran 6,000 battery experiments in just 5 months, work that would have taken human researchers nearly 20 years. The system combined robotics with machine learning to explore redox flow batteries, which are critical for storing wind and solar energy at city scale. The result: the AI uncovered a hidden molecular stability barrier and identified three solvents that could finally make grid scale energy storage affordable. This is what AI looks like when it stops generating content and starts generating infrastructure. India's space program opened 2026 with the engineering win. ISRO PSLV C62 successfully delivered a high resolution Earth observation satellite for the DRDO, along with the 17 international payloads. But the most interesting detail flew under the radar. A small demonstrator called KID stayed attached to the rocket's final stage, turning what would normally become space debris into a permanent orbital laboratory. It's a clever example of reuse without recovery, and it reinforces why the PSLV has become the world's most trusted launch bus for small satellites. Quietly, efficiently, and precisely, this is peak space engineering. So, those are the engineering stories shaping what gets built next. I'll see you in the next brief.